Good afternoon, students. Here I am taking two questions. Find the modulus and amplitude of the following complex number and hence express them into polar form. These are the complex number. Here are two parts. This is a question number 9 and it's a part of the question number 9 and it is a part of question number 10. Okay, here I will, for the first question I will give you hint, but for the second question I will solve actually this part. So the hint is here you need to multiply the numerator. Okay, this is your complete complex number, and here it is the numerator is 1 plus I into 2 plus I and denominator is 3 plus I. Okay, so after multiplication you need to rationalize the denominator, same as question number second, whatever I am going to solve here. See the question number second. Here z is equal, I am taking 1 plus 3i, this is 1 plus 3i upon 1 minus 2i. Okay, so rational, we need to find the modulus. At first we will find out the modulus, but before the finding the modulus we need to write it. Actually it is not in form of a plus ib, so we will create it in form of a plus ib. Okay, so now for a plus ib we need to rationalize the denominator. So z is equal, we will write 1 plus 3i upon 1 minus 2i into 1 plus 2i upon 1 plus 2i. We will rationalize it. Okay, so 1 multiply with the 1, what we will get? 1 multiply with the 1, this is 1, plus 1 multiply with the 2i, it is 2i, plus 3i multiply with the 1, so this is 3i, and now 3i multiply with the plus 2i, so 3 2 is 6, but I square upon, here it's a minus b, it is looks like a plus b, so it a plus ib, oh sorry, a minus b, a plus b, so this is what, 1 to the whole square. Actually it is a square minus b square, so minus 2i to the whole square. So z is what, 1 plus 2i plus 3i plus 6i, so we will set here it's a 1, 2i plus 3i, this is 5i. Okay, and plus 6i square, I square is minus 1, so it will be minus 6 upon 1 to the whole square is 1, and minus 2i means 2i to the whole square is 4i square, and 4i square is what, 4i square is, okay, I will write here the 4i square, I square is minus 1. Okay, so students, we have a 1 minus 6, this is minus 5 plus 5i upon 1, and I square is minus 1, so minus 4, and already here is minus 4, so it will be plus 4. So z is, can we take minus 5 as a common? Of course we will take only 5 as a common, and we have a minus 1 plus I upon here 5. Okay, actually 1 plus 4 is already 5 cancel out, so we have a complex number. You can see it's a minus 1 plus I, and it is in form of a plus ib. Clear? You cannot write it in equal form, so minus, you can just imagine it is in form of a plus ib. Okay, here the real part of z is minus 1, and so students, we need to write it in polar form also. So for polar form you can write here, for polar form, for z is equal minus 1 plus I, or you can write r into cos theta plus I sin theta. This is polar form, so we need to find out r and theta. So for r, this is what, under root, real part of z is minus 1, so minus 1 to the whole square, plus imaginary part of z is what, here what is the coefficient of I, this is 1. Okay, so this is the imaginary part of z to the whole square, so minus 1 to the whole square is 1, and plus 1, so this is root 2, r is root 2. Clear? And now students, very important part, tell me, here we have a complex number. What is the complex number? Z is equal minus 1 plus I. So tell me, this complex number associated with which quadrant? This is here x is negative. If I am asking to you what is the real part of z, you will tell me it's minus 1, and imaginary part of z, this is positive 1. So here it's a minus and positive sign. Minus sign, here is minus sign. It's, of course, this is this will lie in the second quadrant. Here x is negative and y is positive. Clear? Yes, in the second quadrant it will be. So here is minus 1 plus I. So from the concept of finding principal argument, we need to find out here the tan phi, and tan phi is what? Imaginary part of z upon real part of z. You will get this concept from the YouTube links. So student, tell me, what is the imaginary part of z? This is 1, and real part of z, it is minus 1, but because of modulus we will write here the 1, and the value is here the tan phi. Tan phi is equal 1, or we can write tan 45 degree. Tan 45 is also 1, or we can write tan pi by 4. Clear? So phi is what? Phi is pi by 4. But so principal argument, means theta. Okay, so principal argument theta is what? Theta is, for the theta here, it, listen, it's, if this here is a complex number minus 1 plus I am representing the complex number by this point. Okay, so here if this argument, we need to take the argument every time from the anti-clockwise direction, and from the positive direction of x-axis it will be theta, and here it will be phi. Okay, so theta plus phi I am taking. If theta plus phi is equal 180 means pi, so theta is what? Pi minus phi. Clear? Theta is pi minus phi. So theta is here pi minus, the value of phi is pi by 4. Finally students, what is your answer? It's a 4 pi minus pi. This is 3 pi by 4. So we are getting the theta principal argument, what? 3 pi by. So we need to find out here need to write here this complex number in form of polar. So z is equal minus 1 plus I is equal r. So polar form is, you can write here, the polar form is r is root 2. You can watch from here, and bracket cos theta is 3 pi by 4 plus I sin 3 pi by 4. We can check the answer from the book. See the book. This is the book, and here I am taking this question number 13 part second. So question number 13 part second is root 2 cos 3 pi by 4 plus I sin 3 pi by 4. In this way you can match the answers. And students, I am going to give you the work. Now you will solve minimum 3 questions from this part, and you can solve this part, question number 11 also. Question number 11 is your work. Right now you will solve it 11, and okay, solve only question number 11.